Now, without further ado, we'll get to our smart contracts talk tonight by Dr. Alexander Kurz. Thank you very much.
Okay, so can you hear me on Zoom? Can I see whether you hear me on Zoom? Okay, okay, great. Okay, first I want to thank you for the invitation. I've been to a number of talks as an online participant, and I've seen some great talks. So it's a pleasure and an honor to be here tonight. So my topic is on smart contracts. And, oops, my microphone here. Okay, let's see whether this works. So maybe I should say first that my background is kind of on the mathematical side of computer science. So I do logic and category theory and apply that to software engineering. I myself new to smart contracts. I started roughly a year ago a research group with my students at Chapman University. And so if you've been in this topic for years, you probably know more than me. So, but yeah, I'd be really happy to have a discussion and to learn more myself. Okay, so I divided this talk roughly in 4 parts. So just a general introduction, different reasons why we could be interested in smart contracts. Then I want to see how to actually write and use a smart contract. So that's the technical part of the talk. We'll look at a little bit of code, and I'll point out what the differences are to ordinary programs. And then I come to the question, what is a smart contract? So what is really what makes it different? We'll talk a bit about how the consensus algorithm on a blockchain works. And then the part that actually interests me most is like, where do we go with this technology? What's the impact on society? What can we expect in the future? Okay, and also if you want to interrupt me with a question, I'd welcome it. Okay, so why are smart contracts interesting? So I want to touch upon 5 points. So first, technologies, so new technologies, and this is cryptocurrencies and smart contracts. But then I also want to just briefly talk about that there's a lot of media attention, so there are a lot of technologies which are super interesting and very impactful and get a lot less media attention. So I want to kind of explore this also a little bit. Okay, so cryptocurrencies. I put in some links which you can explore if you like so. So the history of cryptocurrencies is very interesting, and yeah, so I don't think we need to go through all the links. Probably it's best you can read up on this. Maybe one thing I just particularly maybe I should point out is this book, Law as Code. So this book is written in 1999, and we can think of it as an early history of the internet. But it is written by a law professor who already at the time kind of thought deeply about the connections between code as a program and code as law. And I think this kind of sets the scene for smart contracts. So people think of smart contracts both as contracts and as programs. And what the book really emphasizes is that what we can do with code depends as much on the law as on the technology. So maybe we all in the room remember the 1990s, the early time of the internet. There was a lot of hope that internet would kind of democratize things, that knowledge would be free, everybody would have access to free knowledge, and then things didn't quite turn out that way. So why is that? It has a lot to do with the way we, with the laws we impose on code, on computer programs. It has to do with intellectual property and all these kind of questions, and they are coming now. We can talk about this at the end again. They become even more important now with respect to cryptocurrencies. So law as code is one of the important ideas here. Okay, so now, how do I go back? Oh no, it opened a new tab. Okay. So, so media attention, probably you're familiar with this kind of, that there's kind of a lot of hype on cryptocurrencies, NFTs. And so a question for us, even if we're not really interested in the technology, even if we don't want to make money by speculating on cryptocurrencies, just like reading all this news in the media, kind of poses the challenge. How do we separate hype from the serious? And I hope I can give you a little bit of background that will help us to assess the media landscape. So why the hype? So on the one hand, there are lots of new applications that this technology offers us. So distributed autonomous organizations promise us that we can run business without intermediaries. It's all in code. People just interact with the code. There's no problems with needing lawyer or escrow. Everything runs on the blockchain. And we all heard about NFTs, and we had a talk here, I think 2 meetings ago, about NFTs. Then the metaverse, people talk a lot about the metaverse. Facebook even changed its name. Another big area is computer games. And then the Web 3. So this is the idea that kind of Web 1 was already decentralized. Then Web 2 is the web of the big platforms. And now the question with cryptocurrencies and smart contracts, can we decentralize the web again? What will Web 3 look like? Will it become decentralized again? And then can we decentralize finance? So certainly one big benefit for people who live in countries who don't have access to banking as we do can use this technology to keep their wealth, to move around in the world, to take their wealth with them, do not have to rely on the banking system in the local country. Decentralized finance, DeFi. And a topic I only became recently aware about, partly also because of COVID, right? So we've seen the damage that COVID has done to our supply chains. So how can we use this technology in order to improve supply chains? So a recent example we had, I order something online, and then a few days later they tell me, oh, but we can't deliver. Maybe if you wait a day, we'll pay your delivery, and so then I wait a day, and then they still can't deliver. So then they tell me, oh, but you have to cancel your order, and then you have to order again. And you do this, it's $80 more. So what's going on here? So they tell me they can't deliver, but then they tell me they can deliver for, so something is wrong here, right? And if we had transparent supply chains, I mean, I could prove that they were lying to me, right? Because the transparent supply chain, you kind of can see beyond beyond the person who is selling to you. So these are ideas which are discussed, and I don't get a good sense for how far they are in terms of getting closer to becoming products and being implemented. But certainly these are things people do get excited about. Okay, so then if you are not interested in all of this and just come here for the entertainment, you can spend the rest of the lecture following these links. It's a wonderful world of true crime. So, for example, the first link is about, so this has to do with these decentralized autonomous organizations I mentioned before. So in these DAOs, people who are holding crypto can vote what is going to happen. They can change the rules. So then you can take a so-called flash loan. Then for like 13 seconds, I think in this case, you are the guy who holds most of the crypto. And then you vote that everybody has to transfer money to you. So 182 million in 13 seconds. Right, so that's interesting. And it's not even clear whether this is kind of a crime or whether this is fraud, because this hacker played to the rules. The rules are in the contract. The contract is a program. So is that fraud even? The second link is about a scam that was worth $600 million. So that's also, I think it's the biggest, or was the biggest at the time. And yeah, so I try to find articles that are interesting to read. Also, what is a really great source of information is this list, which is updated every day. And so we can just scroll through this and see like what happened in September. What kind of, how did people lose cryptocurrencies? So just yesterday, apparently, 160 million, as you can see. And then if you scroll down the list, you see that this happens more. So 160 is of course a big sum, but I mean, basically there's something every day. So 1.25 million a week ago or so on. So actually, this is something where people in my community try to use their expertise in logic and formal verification and formal methods. So can we verify, prove reliable, smart contracts at the time we're writing them, before people use them, right? So this is a bit like when you use a compiler, the compiler can do some verification before you run the program. And so if you kind of add a lot of logical power and machinery to this, maybe you can prove a contract correct before you run it. So that's kind of where I hope in the future to link my past work in logic and computer science with cryptocurrencies. Okay, and then also I chose this paper, Sex, Drugs, and Bitcoin, partly because the title shows that also academics find this kind of area really intriguing and are kind of seduced by, I don't know, all these kind of stories and narratives and crime behind this, but also because it's interesting. They have an interesting methodology. Oh, sorry, I can't, for some reason, I can't scroll this down. Show it on my screen. Anyway, so what this says is This is a quote, supposed to be a quote from the abstract, which says that 40% of all Bitcoin transactions have to do with fraud, with hiding money, with criminal activity. So that's quite a lot, right? 40%. Of course, the question is, how do you measure something like this? And the largest part of that paper is about the methodology they use, and I'm not an expert in that area to assess whether kind of how robust their methodology is. But I thought this is interesting to mention. Okay, so then this is a slide about science fiction and cryptocurrencies, and I planned this slide when I mapped out the talk, and then I didn't have time to really do this slide. And I already admitted that I'm not a great expert in cryptocurrencies, so this is just something I picked up a year ago. And I'm even less an expert on sci-fi. So I like to read, but I almost never read sci-fi. So if you have any recommendations for me here, I'd be really interested. So what I do know is that kind of the crypto community in the 1990s, which kind of got this whole thing on the way, like how to use cryptography to keep people private, to guarantee anonymity on the internet, how to kind of set up a system where individual people can kind of fight against the government. There's a whole movement in the 1990s, and they kind of were very much inspired by science fiction, even to the extent that the cypherpunk mailing list, on which many of these innovations were discussed for the first time, was named with a reference to cyberpunk science fiction. So yeah, so this is also kind of, I think, a little piece in the puzzle to understand better the media attention, right? So this connection of this technology with kind of storytelling, science fiction, and so on. Okay, so after this introduction, so now I don't know how much time I spent on the first part. Okay, so let's look at a smart contract. You're sitting very far away, right? So I'm not sure.
Can you talk to?
You can see this.
This is a smart contract.
Yeah, this is. I give you an example here.
Okay.
That's why I have this slide, but I'm not sure. Can you see roughly what's there? So first of all, we don't need to go to the details, right? So I just put this up first of all to say, if you see a smart contract for the first time, it just looks like an ordinary program, right? And so it's called contract, but it's just a program. It has a name, right? So pay and guess. So this example is just very simple. You have a method which you can call, and then you pay money into some pool. And so this function is called bet, right? So you're betting some money, and you're also making a guess. You guess a number. It's a number guessing game, right? So the first function pays some money and guesses the number. And then the second function is just paying out this money to right? So you can think about, I put the dots here, so the algorithm which determines the winner is not on the slide. You can put in whatever you want, right? So maybe you choose one of the players who put money in at random. Or you choose a number at random, and then you choose the player who is closest to the number you've chosen, right? So kind of anything. The interesting thing in terms of what is a smart contract is not in the algorithm that determines the winner, but the interesting thing is about how these functions interact with a smart contract and what that means for the payments. Okay, so maybe I should say that this example is real code written in a programming language called Solidity, and it runs on the Ethereum blockchain. This is not really interesting for the big picture, but just kind of so you know that this is something that runs. And okay, so going a little bit more in the details, each smart contract, so this whole thing is a smart contract, can hold some money, has a balance. And so somebody uses the function bet in order to transfer money to the smart contract, then this money is in the smart contract and you cannot get it out in any other way than by calling this other function that is defined in the smart contract. So kind of the key idea here is that fraud is impossible. Actually, nice contrasting nicely with the slide I had, right? So I had the slide with $600 million frauds, right? And now I'm saying actually fraud is impossible, right? So if I bet my money, nobody can run away with it. Because the only way to get money out of a smart contract is to call this function. And it's up to me to read what is hiding behind the dots, right? So I can read what the algorithm is that is executed when the function disperse is called. And so I can verify for myself that what's going to happen, right? So that's kind of the key idea here, that the whole behavior is laid out in code and making fraud impossible. Does this help with your question? What is a smart contract?
Unfortunately, no. I am struggling to figure as to how all this would be different from having something running not on Ethereum or blockchain or any of this. If you are just running it.
Yeah, so if you're just running this, say, I could have a platform, right? So just some server. This could run on a
I wrote this code on AWS, and I'm the only person who knows the algorithm.
Yeah.
I put it out.
Yeah, but then it depends. But then you have to trust AWS that they are not running away with the money, right?
Yeah, no, I have to trust Ethereum. Somebody has to trust.
No, but okay, so you have to trust Ethereum, but Ethereum is the code. Okay, so the Ethereum blockchain, I'll come to this a little bit later, I can also say this now. The Ethereum blockchain is running on what is called the Ethereum virtual machine. And this machine is kind of defined by open source code, which is on GitHub, and you can just go there and look at it. I mean, if you really don't trust the Ethereum kind of community, you can just go and verify it yourself by reading through it. And I can't do this with AWS. Also, the code base is also much smaller.
The source nature of it that's giving you the trust. My question is it the open source, the fact that it is open source, that gives you the trust, or is it the fact
it's
that
part of it. It's part of it, yeah.
It runs on blockchain, and so all your transactions are non-repudiable. What is it that is giving the trust? And how is it different from a conventional?
So you're right. So that all past transactions that happened are publicly available. That's also important for the trust, right? But if I want to trust that nobody runs away with my money, I need to trust that nothing bad will happen in the future. So these are kind of two different things. So there's a whole bigger story about it, and we can discuss this when I talk about how this kind of blockchain actually works, right? So here I'm just talking about kind of the smart contract, and we can kind of think about it on a level of abstraction that doesn't force you to understand how the blockchain works. Okay, so to highlight kind of what is new here, so maybe this is will also partly address your question. So Etherscan is a program that you can use to inspect the blockchain, right? So I still don't explain in this slide how the blockchain works, but we get to look at it, right? So that's maybe the next step. First we looked at the smart contract, now we get to look at the blockchain. Okay, so the contract, the smart contract, is on the blockchain. So maybe we can try to understand what it means. So first of all, it has an address that identifies it uniquely. So the blockchain is implemented by nodes. There's a peer-to-peer network. The nodes can be anywhere in the world, but every node, when it sees this kind of address, it knows that this corresponds to this address, identifies uniquely this particular contract. Okay, so then we can look at the code. The code is a bit more complicated than the one I put on the slide, but that is not the important part here. So one thing that is important maybe is something we briefly mentioned. So all past transactions that ever happened are publicly available. So here we get to view all the past transactions that involve this particular smart contract. And so, for example, you can see that there was a transaction 3 days ago, and that was myself betting some money just to be able to show you something, right? So also maybe later after the talk, if you want to see more details, we can go through this in more detail. Okay, so that's we've seen the smart contract, we've seen the transactions. Now, how do I interact with such a smart contract, right? So we have these two functions that we need to be able to call them. And so here I can see the two functions. And when I enter something there, then I trigger the transaction. But before I can do this, right, I need to, before I can send money, I need to connect with my own wallet, which I cannot do here on this machine because I didn't install it. So what you do is you click here, right? So then you connect your own wallet, then you put in the amount of money, in this case you want to bet, and the number you're guessing, and this moment you click right, this transaction is sent to the chain. Then if you actually do this, you will see that this takes some time. This is kind of part of the algorithm that creates the consensus. We'll talk about that in a short while. So it's not as fast, for example, as a client-server architecture. You have to wait maybe 10 minutes before your transaction becomes effective. But then the money is in the smart contract, and nobody can take it out in any other way than by triggering the disperse function. So, any questions? Did it become a little bit more concrete now? Of course, I didn't yet tell you how the blockchain works that is underlying this whole thing. So that comes next. Okay, so maybe you bear with me. And let me see. Oh yeah, I need to go back to the tab here. Okay, so that's comes in the next section. So my answer to what is a smart contract really means that we need to understand a bit how blockchain works. So I try to put this in one sentence, but this sentence doesn't mean too much. So there will be more detail on the next couple of slides. So, but maybe very roughly, a smart contract is a program on a distributed computer, and this is in double quotes, such as the Ethereum virtual machine. So we can think of it as one computer, right, which has a distributed implementation. And then the crucial thing that makes everything work is what is called distributed consensus. That's what I want to explain next. So what is distributed consensus? Okay, so first, a remark on terminology. So when I prepare this talk, I try to find out what is kind of the general, is there a general agreement on when you say distributed and when you say decentralized? Sometimes seems to depend very much on the context, which are the two words one uses. So maybe roughly distributed also includes client-server, whereas decentralized means tends to mean peer-to-peer architecture. So that's an important difference for us. And maybe another distinction one can make is the kind of fault tolerance you require. So fail-stop fault tolerance means that you have the means to recognize whether a component of a system fails. And Byzantine fault tolerance means you don't even know whether your components fail, right? So components can stop behaving according to the agreement without letting you know. By default, every component can be malicious. Of course, if every component is malicious, the whole system wouldn't work. So typically you have assumptions like not more than half of the components are malicious or something like that. Okay, so we are interested in the world where our cryptocurrency runs on so-called nodes in a peer-to-peer network, and we don't want to trust anybody in the network in particular. So Byzantine fault tolerance is what we're interested in. Okay, so I use this picture to explain in rough terms how that is going to work. So transactions are recorded in so-called blocks, and the green block here is just the first block which was created. And then maybe there are some more transactions, right? And there's another block appended. So more data written into the ledger. But then the question is, like, how do you do this in a distributed fashion, right? So if there's no cooperation between the so-called miners, so the miners are the guys who are kind of creating the new blocks. And they work in a distributed system, so we can't actually avoid what is also called forking the chain. Right, so we can't avoid this because they are working concurrently without even knowing of each other. Okay? And now you see that when it comes to currency, this is a really big problem. Maybe that's not a problem in all peer-to-peer networks, but say I own a coin and I spend it here and I spend it here. Right? So if I'm able to spend a coin twice, that would be a huge problem for a currency. So it looks like this problem doesn't have a solution, right? So we want a distributed solution. So the miners work independently. Every miner can just decide which transactions to put in a block, right? I have two transactions. I spend my coin twice. One miner picks up the first transaction. The second one, the second one. And for each miner, everything looks fine, right? So you can check that no coin is spent twice on each chain, right? So that's easy to check. But this miner doesn't know about this miner. So this miner has no way of checking that I didn't spend my coin twice, right? So how do we solve this problem? And this is where this concept of proof of work consensus comes in. So each miner has to solve a puzzle. And this is like searching for a needle in a haystack. So it requires a lot of computation power, and there's no way you can. The puzzles are made in such a way that there's no way to kind of. You can play a trick. You can cheat. You have to solve the puzzle, and you can't accelerate this. Maybe you buy better hardware, for example, right? So this is why buying special hardware for the miners is such an important topic. Okay, so what's happening now is that one of the two is solving their puzzle in a shorter time. Okay, so in this picture, it will be this one who solved the puzzle first, and we can see this in kind of how this. We see this by looking at how this picture kind of evolves in the future. Right, so here very important is the idea of incentives. Right, so the miners obviously need to have an incentive to participate in this. So this is why they typically get paid with some cryptocurrency, right? So now, if I'm, say, this guy, let's look at these 1, 2, 3 blocks here, right? So I'm a miner. I want to earn the cryptocurrency, and I see that this guy already finished. Then I want to append my block to this one, not to this one, which is actually not even there yet, right? And so the idea is that just by randomness, by exploiting randomness as a resource, together with the incentives that the miners have, there will be always one branch in the chain, which is not a chain but really a tree, that grows faster. And after some time, these kind of slower branches will be abandoned. It would be contrary to your own incentives. This would be contrary to your interests, right? You want to get paid to try to append a block to a shorter branch. Okay, so that's kind of the basic ideas. Is this more or less? Does this more or less make sense?
But where is the consensus here?
Oh, the consensus is that this black chain here, very good question, that this is the chain, right? So really it's a tree, but the double spending problem forces us to select one branch in that tree. So the consensus is like which of the many branches of the tree is the chain? That's what the consensus establishes.
But if you were to take your example.
For questions, let's make sure we get a microphone.
Yeah, if you were to take your example of, somebody who pays twice for 2 different transactions, and what you're trying to capture is which is the real one or which is the first one. Okay, so how does this consensus identify the first payment as being the correct payment and the second payment as being false?
This is a brilliant question, because you asked like which is the correct payment, and there's no reference to any standard of truth or correctness outside of the chain here. And so what essentially happens is that one of the 2 transactions will be declared the correct one basically by randomness, a random choice. There's no way to kind of decide this question in an objective way. It's just that the algorithm is set up in such a way that if you wait long enough, then with very high probability, one transaction will be on the longer branch. And that's the one which kind of, by the action of the other miners, kind of wins and becomes the true one. Another thing one can explain here is that if this is the 51% attack, kind of a famous thing in cryptocurrencies. So now imagine that I own 51% of the computing power, right? So then I can just say, oh, let's grow this branch. And if I own the majority of the computing power, I can grow this branch so long that it becomes the longest branch. Right, so this is kind of refers back to what I said about Byzantine fault tolerance, right? So with enough malicious nodes in the network, you can always subvert the system. Yeah, and any more questions to this? So that's the end of the technical part. So the rest is just kind of talking about some things. But if you want to talk more about this, I'd be happy to deepen this part of the talk as well. Okay, so. So where to go with this, right? And one thing I find fascinating about this topic is that it raises a lot of questions that weren't kind of general interest just only not too long ago, right? So for example, what is money? Right, so maybe this would be a question of interest to philosophers or anthropologists or economists, but I don't think it was like considered to be a difficult question that is of societal relevance now, right? But it is now, right? Because like, is cryptocurrency money, right? So does Bitcoin have an intrinsic value, or does the value of Bitcoin that just comes from kind of criminal activities which use it as a storage of value? If you would stop, if the US government would outlaw trading dollars for Bitcoin, it's pretty clear that the value of Bitcoin would immediately collapse. Or maybe not, right? So maybe there's enough demand for Bitcoin in the rest of the world. I don't know, right? So, but kind of, is the dollar and the Bitcoin the same kind of thing? Like, are they both currencies or not? It's a really interesting question, and I think the answer is not clear at all. And there are many questions like this in this area. So, for example, what can be decentralized? So what Bitcoin proves is that at least if you put in enough computing power, so I think one Bitcoin transaction consumes more energy than a month of a household in the US or something like that. It's stupendous. So you could say Bitcoin actually doesn't work, kind of, yeah. But let's ignore this, right? So because there have been also other suggestions than proof of work of how to create distributed consensus. But even if we assume that distributed consensus works and scales, right, which is not really clear, but let's assume this, right? So then there is still the question: what can be decentralized? So Bitcoin then shows that kind of agreeing on transactions, creating a public ledger, that can be decentralized. But say, what about social media, right? So there are a lot of debates about whether social media actually kind of what value it contributes to society. And could a different form of organizing social media, maybe without advertising, for example, be an interesting architecture, right? So, for example, if you can buy Twitter likes on a market, which is actually the case, right? So then, kind of the value of the likes becomes like kind of doubtful, right? But some people think Twitter is a public town square. So doesn't the fact that you can buy, that you can pay for your tweet becoming viral subvert the public town square kind of function of Twitter, right? So that's an interesting question. But it's not clear whether something like Twitter can be really decentralized while still performing the role we expect. So what can be decentralized? What service do centralized platforms actually perform? I think that's also not so clear. And would decentralized social media kind of be more compatible with our democracy? Would that be could a more healthy democracy arise from decentralizing social media? So there are actually decentralized social media. So I put some links here if you're interested. And there are also research centers which research these questions. And then I should mention Vitalik Buterin. He's one of the creators of the Ethereum blockchain and one of the main contributors to this programming language, which I showed you, that smart contract. And his blog is, I think, always very interesting if you want to kind of get a sense of where this whole where this whole field is moving and what discussions are kind of interesting. So I put, let me just show you that this is all clickable. So if you're interested in getting more information, right, so then you here get a kind of a list of blog posts by Vitalik Buterin on this topic of decentralization, for example. Okay, so this is an interesting question. What can be decentralized? So then, how can we make smart contracts actually really be reliable, right? So there's this kind of paradox, which I said, when I showed you the smart contracts, I said, fraud is impossible, it just runs. And then I showed you the list with all the frauds where people use hundreds of millions of dollars. So what's actually going on here, right? Kind of even if we could make them reliable in a technical sense, right? So could we make them a reliable tool in society, right? So that's a different question, whether a program meets its kind of technical specification or whether a program works, aligns itself with respect to human values, right? So that's a totally different question. And so one particular point here is that once you have once you deploy the smart contract, you cannot change it anymore. But that's not the role that contracts play in the real world. In the real world, maybe you go even to court, and then there's a lawyer and a judge, and the meaning of the contract is up to negotiation in some degree, right? But a smart contract, there's no negotiation whatsoever. And so some people think of this as an advantage of smart contracts, but is it really an advantage, right? Could we run a society just based on smart contracts that are not up to renegotiation? Or what about bankruptcy? Right, so bankruptcy obviously plays a super important role in our economy. If we design an economy where you wouldn't have bankruptcy, you also would have much less innovation. You would have much less entrepreneurship, right? So it's part of the system, but it's very difficult to see how bankruptcy would work in an economy based on smart contracts. There's no such thing as bankruptcy, right? So the money just goes around, and then, okay, if I run out of money, I can't initiate any further transactions. But that's not the real life.
Hi, my name is Susan. When you have a smart contract, the back end of the contract would have the consequences laid out. If X does not, then this will be the consequence. If you don't pay your rent, the lock will not open.
Yeah, that's...
These are the consequences.
Yeah.
So smart contract can be as simple as buying a ticket to a concert and looking at that QR code as being a smart contract, and the agreement is your entry into the facility and watching the concert. So we're essentially grooming ourselves to think.
Yeah, so I agree with what you're saying, and this actually opens up another question, namely how to connect on-chain with off-chain events. That's also a really interesting problem, right? So what I said about smart contracts, fraud is not possible, everything runs as programmed, only works as long as all information is on the chain. But opening a lock is off the chain.
In the contract.
Yeah.
The contract lives on the chain.
Yeah, the contract lives on the chain. It's data on the chain. But the lock is not, in your example, the lock of the house. Right? So even if the contract thinks I'm opening this lock, maybe it's opening a totally different lock or no lock at all. Right? Because the lock is not on the chain. When I write a smart contract and I deploy it, I cannot verify that this smart contract will actually open that lock.
That's what the agreements are that are written in Solidity.
No, because the lock is not on the chain, so no smart contract can verify that it is this lock which will be opened.
actually, that's part of the charm of a smart contract, that when you do those agreements, deploy those triggers. So if X happens, I get a notification that my shipment just left the warehouse in Upper Marlboro. And then when it gets onto the truck, I get another notification. And if those agreements aren't met, then there are consequences.
I agree with all you're saying. All I want to add to this is that as soon as the smart contract interacts with the external world, there is some additional trust that is needed. And this trust doesn't come from the consensus algorithm that the miners are running. That's all I'm saying.
The stakers, they're no longer miners. With the Ethereum merge last week, they're no longer
okay, so
their stakes.
I want to, but I don't think that changes my general argument.
Okay. Thank you.
But if I'm using my phone to open that door, and this is part of the chain.
Can I use the microphone?
But the door is
Can I use the microphone?
I see what you're saying. Okay.
Like shipper. For example, your shipper. I've shipped a lot of stuff. And trust me, lots of reports that it left the building, it didn't leave the building, it was still there. And all the electronic stuff, all the reports said it shipped. It didn't physically ship. So there is that interface between physicality and what's...
In a perishable business of produce where I'm bringing in product from all over the world, it's imperative that I know the systems in place, and the blockchain is very, very attractive.
But
because
physically,
there are controls.
that perishable item is not on the chain. You don't know where it really is.
Well, all right, so if the smart,
Please make sure you use microphone.
so we're doing it today physically. So when the warehouseman loads the truck, there is a agreement that is met. And then when that truck hits the distribution center, there's another agreement met. And then when it gets slotted in the warehouse, an agreement is met. When it then gets back on the truck, an agreement is met. Then it gets to the store, an agreement is met. And that's essentially...
Inside the box is your product. It may not be.
Okay, gentlemen. Thank you. Are you a developer, blockchain developer?
No, but I have shipped billions, hundreds of billions.
I was a corporate director for Safeway.
Okay, I am a Solidity developer, and I think what you're talking about, generally speaking, is the Oracle problem. You have inbound and outbound oracles with smart contracts. So that event that gets emitted when the box ships from location to location relies on trusted oracles, and there's a company called Chainlink that's really big in this space. I shouldn't say a company because it's really more of a DAO. And you have a combination of oracles and emitted events with the smart contracts. So when an emitted event goes out somewhere, you pick it up on like services like Alchemy or Infura and such, and that becomes your truth for what's happening on the blockchain.
I write in Java and Solidity. I'm a blockchain developer because I wanted to do a better job.
So anyway, thanks a lot for this. I think that also matches up with how I think about this.
The Oracle problem is consistently talked about in the whole blockchain space.
Did you follow the merge last week? Huh? It was big for the whole industry.
So I see we'll have an interesting discussion after this. I just want to check like what the kind of constraints on the schedule are. I can finish any time now, so just tell me what, and then we can go to discussion or like.
Take some questions from Zoom participants.
Okay, so maybe I just go, let's see, I just have like one or two more slides, so let me just, so we talked about this. I mean, we talked about this, the question that interests me that is kind of relevant, maybe not central, but maybe it is, right? So how to finance public goods, and there's some interesting work which I didn't study yet really, so I'm looking forward to look at this work by Alex Tabarrok on this topic, and there's also a blockchain implementation apparently of his algorithm, so that looks like a really interesting thing to follow up. We talked about off-chain, on-chain, interesting topic, reputation and trust, right? So blockchain is supposed to run in a trustless environment, but can we run our economy in a trustless environment? No, I don't think so. So how do we establish trust in kind of based on smart contracts and this technology? I think I mentioned, so the last point is, I think, is also interesting about constraints versus incentives. So if you want to create institutions that work, you should think about constraints and incentives. And what smart contracts make easy is to think about and implement constraints, but incentives, I think it's more difficult. That's at least the impression that I have. And yeah, so I just have some references. Maybe I want to mention that I find this book by Guri about the revolt of the public and the crisis of authority super interesting. So on the surface, it's about social media. But more generally, he asked the question about networks versus authority. And or rather, I should say, authorities versus the public and networks versus hierarchies. And I think a lot of this has kind of bearing on understanding where blockchain technology is going. So I find this super interesting. And then another very interesting topic, I think, is the question, again, one of these philosophical questions that are asked by this new technology is, what is cooperation? And there's a huge kind of literature coming out in the last decade or so. Primatologists, anthropologists, psychologists, economists, like Bart Wilson is an economist at Chapman University, philosophers, and so on, who are kind of exactly studying that problem. And I'd be super interested in kind of maybe even kind of getting some kind of ideas out of that literature, and then say, I'm a software engineer, I'm going now to test these ideas by implementing softwares, by implementing networks, which I run in the real world, and then we can actually kind of see what happens with these ideas in a kind of experimental setting. Okay, so but I think that was really my last slide. So I want to thank my students with whom I've been working on this since June, right? So it was maybe a bit before that. It's super interesting, and great students we have at Chapman University. And then some colleagues from the UK. I worked in the UK before I came here. And then also like great colleagues in Chapman University, economists. Tom Bell is a law professor who also works on distributed autonomous organizations. And then I thought I close with one quote by a science fiction author, because I want to come back to the science fiction topic as well. And yeah, so that's it. Thank you.
Okay.
Oh yeah, so questions from the Zoom audience. How do we do this, Michael?
I don't see any right now. They've been using the Q&A channel to complain about the audio quality.
Yeah, just to state, yeah, we're aware of the issues with the audio and trying to fight that all evening, but we are aware of that. Any questions in the room?
Perhaps I'm missing something in this clarification shift question.
So I understand how you can label a box. And yes, that box got picked up. But you have to trust whatever it was that detected the box, whoever entered the data. There is a level of trust beyond your system. There is a level of law and contracts that says, dishonest shippers put the right product in the box. or if you are to design a shipper and you put the wrong product in the box, there are going to be consequences, and it's outside of the trust of the network.
Looking at it a different way, you pick the fish that you're buying, and you scan the label, and it tells you basically where it came from, how long it was in such and such a warehouse, and then et cetera, till where it was actually, was caught, and so on. So when you look at that way, this is already a trust, so that data was pretty much verified till you picked up this, piece of fish, from the supermarket. So all those boxes that had content in it, till it was actually, was distributed to the end user, because at any point when it opens up and wants to get delivered to the end user, if it failed, then then the chain breaks,
Mark, we need to ask that professional organization question. Could you ask that in the microphone before we continue with the real questions? We're going to do a poll.
We're going to do a poll real quick. So traditionally, our first question is how many of you are IEEE professional members? So if you are IEEE, raise your hand. And then we're going to have a poll go out on the Zoom as well.
So it's IEEE or IEEE student branch or ACM chapter?
Yep, IEEE student, OC, ACM chapter as well.
There's a poll up there. If you're a member of anything, they check the box.
It's obvious that you have a very good experience in warehousing and distribution. Nothing ever goes smoothly, and so you have to anticipate. And the trust level, I'm in the perishable category, so produce to flowers. And in the PMA, the Produce Marketing Association, we talk about traceability and how important traceability is. Mm-hmm. And that goes from soil health to amendments to how it was, is it a 40 centimeter rows? How many stems? Lots of knucklehead stuff occurs because us humans will always be involved. But what's so attractive about a smart contract being deployed between the receiver and the seller is that series of steps are triggered, and that there will be, Elva will be able to know the shipment left the farm, and then it's on the truck, it's on Prime. And so you can then also be able to match up your temp tails to see what the temperature control is. So there's a lot of controls. Is it perfect? No. And are we there? No. But I think that it's a system that's very, very attractive, and I love your explanation. It was really well done. So kudos to both of you. But I think that the smart contract has a lot of potential in warehousing and distribution. Even just having a dinner party that I'm having where I'm selling an NFT for people to attend a dinner. They get this memorable image, but it's the contract on the back end is dinner.
There's a question. There is one question on the Zoom, which is, any thoughts on chain link?
He addressed that.
Oh, we did, okay.
You want to talk about co-ops?
So actually, I would be super interested in this supply chain thing, and I'm interested also in finding concrete topics which I can do with my students. So some of my students are really talented software developers, but I need to find kind of something interesting for them to work on. So if you know in your professional life something that a student could try, right? So I mean, probably a student would be able to immediately contribute to a big company, but like just something could be a proof of concept implementation. But I'd be super interested in hearing about kind of concrete projects like that.
I got a very simple question. Everything that you just said need not be implemented on Ethereum, need not be implemented on Solidity. It could be implemented on any other system that you could trust.
Yeah.
And it would give you, as a user, the same kind of information, provided the data is, trustworthy. So why is this platform and this whole new process of learning all these concepts and learning a new language. Why is it important?
So
Why
one
can't I
thing,
write it on Python and AWS, and will it not satisfy your need?
The important thing is, sorry. The important thing is being able to change invoices in between. Once you have this chain, anytime you go and try to change something, you violate this entire chain. So that's why this chain becomes very, very critical. Whereas in all those systems that you mentioned, all the typical server, client-server models that we have today is that I can go and change something and so on without really affecting the rest of the things that are happening and so on. Whereas here, you don't have that option. And that's the beauty of the system.
but I want to also add something. Can I just add something, because I think it's relevant? So there is a difference between permissionless and permissioned blockchain. And I think that's important, because I think your question goes in this direction, right? So if you have a trusted authority, then you can have a permissioned blockchain, which still has the properties are important to you, like traceability, immutability, persistence, without having to run all these nodes in a distributed network in order to create the consensus. Right? So it is possible to just take out the kind of ledger aspect without also taking the distributed consensus part if you trust a central authority.
No, but I think it's going to drag. I want to pass on this.
No, perhaps I can give you an example that I see from my own, having built military command and control systems. Many of these characteristics that they're seeking exist there. You don't take commands unless it's coming from a command authority. You don't allow commands to be modified. Non-repudiation is in place, but it's very centralized. It's very custom. It's not open. It's not extendable. So it really is a question of what's the set of requirements you're seeking. So, yes, these things have existed for many, many decades, but they were custom and specialized.
My question was very specific to the use case that was just discussed, supply chain.
Oh, yeah, but again, I would use that as an argument. So you could do these things. You would do it in a very custom, centralized fashion with planning it all out, and it would be very complex and probably very expensive.
So I think in the supply chain example, even if you do it in a permissioned way without the distributed consensus by the miners, this a blockchain would still give you something, because as you said, things can't be changed. So maybe it wouldn't be the miners then who kind of are verifying everything, but you could think about a journalist looking at the data, and maybe it says the fair trade coffee I bought actually part of the money I paid was actually paid to a farmer, right? So I can't verify this. This verification is not on the chain, but if everything is traceable and persistent, a journalist could come and say, okay, I trace back all these things, I find the guy I ask him, right? So there would be still, could be still a huge improvement on things we have today.
One other piece I add to it is that you also have to look at the open and the closed system, I can have this, supply chain, it doesn't have to be necessarily open to the entire public, to the entire miners and so on. This can actually be a closed system, but unchangeable. So I'm using a lot of blockchain characteristics, a lot of architecture to really secure the data and make sure that if this fish was supposed to be kept at a certain temperature for so many days in this sort of a refrigerator and so on, all of those have been met before
That's
I can.
a feature of the blockchain, not the smart contract.
But you're building that into this, it's because by itself doesn't exist. You have to have that smart contract in order to happen. Interesting.
I'm not quite sure what I can add to this, but one of the ways I think about this, especially with the fish example, is you've got the fishermen, the dock workers picking up the fish, transport to the distribution center or distributor, then going on to the store, then going on to the consumer. And today what we typically rely on is a centralized authority to guarantee the provenance of those goods, the provenance of that shipment. Under a blockchain and smart contract system, each of the individual players in that chain don't have to trust one another, because they're simply recording information on the blockchain and using these inbound and outbound oracles to certify that information is correct. That part may not be perfect, but like groups like Chainlink, they're about basically creating bonded services so that if you don't provide reliable information or correct information, you get financially penalized. So that's the way I think about it.
Smart contracts.
I'm sorry?
I think that's the beauty of smart contracts.
Yeah. That she said, yeah, that's the beauty of smart contracts. But to change topics, do you have any thoughts on Nakamoto consensus and making it green, making it more energy efficient?
I think it's impossible.
Well, there's something called network-bound proof of work, which has been proven to be very energy efficient.
That's a different. Okay, I see. Yeah. So no, I don't. I
was just thinking about that for your students. If
you
have interest, I have interest.
Yeah. No, I don't. Yeah. That's a good question. Yeah.
So based on that, the Ethereum merge was exactly that, going from proof of work to proof of stake to help the cost of gas and to reduce the impact, the energy impact. And in time, improve the time lapse of transactions.
I have a different question. Do you have any comment on CBDC? You think we're just taking our time too long and China is just going to kick our butt? You know, there's so much ahead in that area.
What is CB?
The central bank digital currency.
Oh, okay. Yeah. So No, I don't. I mean, I'm interested. I'm talking to economists about this kind of stuff, but I don't understand this yet. I think it's interesting, but something I want to learn more about. But I don't know. I don't understand it yet. No.
For those of you who are interested, basically, U.S. government is working actually with MIT for the last 5-10 years, and they publish a lot of papers. So anybody's interested, they can actually.
Maybe we can exchange emails or something, and we could keep in touch on some of the topics.
China actually announced their digital currency, last Olympic, the Winter Olympic, and they're actually using it. And part of their activity is they're trying to basically implement that as part of their road initiative that they have, to make that a default currency for that.
So you're following Maxine Waters and the Finance Committee, what they're doing?
Yeah. Okay. I mean, we are way behind, on that front.
Why would you just outlaw it all?
Huh?
Just outlaw it all.
What is it?
We outlaw it all, and then it goes away.
No, it's not that. It's basically, if you look at the road and rail initiative that China has, that over 100 countries are part of that. Sure. They're making their digital currency as a default money for that, which basically means pulling U.S. out of the entire economy. What is happening in that chain. So by doing that, they basically pretty much going against directly of U.S. dollar. While we're debating it here, they're actually implementing it and moving forward, and nobody's paying attention here. It's interesting stuff. Sorry.
They say only 1% of the world knows any. 1% of the world, I'm told, only knows about this approach. And so we're all kind of ahead in terms of smart contracts, NFTs, POAPs, cryptocurrency. So there's a lot to learn about. And as I said to staff at Maxine Waters, I said, making policy before you actually see everything play out is kind of dangerous. So there's a lot, it's a wild, wild west. It's
On the
very
other hand, your
exciting.
example was that China is making politics
No, I
already.
mean, for them, the notion of privacy doesn't exist. So in U.S., we are concerned about the privacy. We are saying, well, if I give you $1, now it's trackable. Whereas over there, nobody cares. And my argument when I'm talking to people over here is that look at it. Look at our credit cards. For the last 30, 40 years, I'm using the credit cards. They know every single thing about my life. So here we're making a big deal about privacy when there is really no privacy. We're basically trusting a lot of private companies to have our personal information, and so on.
Well,
So,
we
yeah.
trust private companies more than the government. That's, I think, the
Yeah, but I mean, look at the
thing.
Apple. They have every single thing about my life over here. They look at Google, the same thing. And everybody's okay with it, and they're making a big fuss about the government that is going to have access to information. Whereas over there, they're moving much faster. And yeah.
You're probably aware of this, but in China, they had those bank runs where the citizens were going to a couple of banks where they had lost a huge amount of money, and they literally just shut them off from their bank accounts. And so when with CBDCs, there's a huge danger, in my mind at least, that you've got totalitarian control that can be implemented. As soon as you can censor money, as soon as you can track and trace every transaction, because at least we have cash, then that provides a huge amount of power to centralized authorities, and I think hopefully with cryptocurrencies we're on the path to decentralization.
But do you think, I mean, many thinkers in the crypto world think that the government shouldn't have the ability to create money?
I have always felt that the government should not have monopoly control over money. If you go back to the Austrian School of Economics with gold and silver, and the founders of this country, that was their feelings as well.
But would that work in practice, right? So you have a financial crisis, companies are running short of cash. If you can't inject cash in the economy, these companies go bankrupt.
This is where we wind up with the Keynesian malfeasance we have today.
Yeah, but that's, I think I don't see any way out of it, right? Because you can't let healthy companies go bankrupt just because of a lack of cash, a temporary lack of cash, right? So I don't think that would be such a good idea.
This gets into a deep ideological and philosophical conversation. I think you can go to the Austrian school versus the Keynesian school and go through a lot of the arguments on either end. But I think it was like Hayek, who was an Austrian economist, who pointed out, this is back in the early 70s, so 50 years ago, that he foresaw a world in which we had non-national currencies. We had competition amongst currencies. Bitcoin being the first one of those, I think, in reality, beyond gold and silver. And I think where we're at today, from an economic standpoint, is we as a community, we can all say, hey, we love Bitcoin. Bitcoin should be worth $1 million. It's not tied to anything physical anymore. So if the community decides that it's worth more money, that expands that part of the money supply. And we're entering a post-Keynesian world, I think, one way or another, because governments have fundamentally lost control, monopoly control over money once Bitcoin came along. That's forever gone now.
I'm not so convinced. So, like one thing governments, at least at the moment, still control is taxes, right? And so as long as they can have monopoly control over taxes, they also have monopoly control over money, because everybody has to pay their taxes in say, dollar in this country.
Sure, and that's where we're seeing, like, you can now pay your taxes in Bitcoin and
But
Miami.
that's up to the government to allow or not, right? So the government could refuse this change of law, right?
What was the one today? PayPal was allowing you to pay some form of taxes through PayPal and Bitcoin to, I think it was through Robinhood or something, so you could pay part of your taxes there. I mean, I would expect, I follow a guy named Balaji Srinivasan. I don't know if you've read any of his stuff.
I don't think so.
He's former CTO at Coinbase. He's a former teacher of mine. And he taught at Stanford. He actually taught one of the early crypto courses called Startup Engineering at Stanford about 8-10 years ago. Anyway, long story short, he likes to talk about how we're going to enter into a, quote, network state, where we'll have associations amongst ourselves, maybe we'll have red zip codes and blue zip codes, and people will start freely associating. Some will go toward the crypto end, some will go to the government handout end, like you were just talking about with the post-Keynesian system.
Michael?
From John Bonnell. If every transaction is on the blockchain for anyone and the IRS to see, if you know who owns the wallets and eventually these things eventually come out, won't this make it easier for governments to keep tabs on us?
Yeah, so I mean, one thing is that the transactions are for everyone to see, but what is not for everyone to see is like which transaction is connected to whom in the real world. That's not for everybody to see. Yeah.
Yeah, and the other advent, you have these new systems like you got Monero and Zcash, which use zero knowledge approaches to basically shield the transactions. So you can have privacy while still having transparency of the money or the amount and flow of the currency or the volume of transactions.
Tornado?
Tornado Cash, I think, a little bit, yeah.
So just really quickly, you were talking about the former Coinbase CTO Balaji Srinivasan?
Balaji Srinivasan.
Much better said, but I'll follow him now. Thank you.
Yeah, no, he's very big in Twitter. Yeah, I was just going to say, he's huge on Twitter, and he's got a pretty good following amongst, I think, a lot of crypto people.
Any other questions? Questions on Zoom? I think we're right about at time. So. So for our virtual webinar folks, we do post the videos and the talk of this talk. So if you missed any of the audio or any parts of this, you can see this on our YouTube channel very shortly. So thank you very much for joining us, and look forward to our next meeting together. Thank you.
Thank you for coming.